it's the same thing as what we did up there. Example 5 though says evaluate the 6 trigonometric ratios of 32 degrees by using a calculator. I can't talk today. Evaluate the 6 trig ratios of 32 degrees by using a calculator. All we're doing here, we're finding the sine. Well, let me do it on this other sheet. The sine of 32 degrees. Here's something I need to caution you of. Something I need to caution you of. Under mode, make sure your calculator is in degree mode, because right now it's in radian mode. Right there, at the very top. Hit the mode key, go down to, instead of radian, go over to degree, hit enter, and then, because if you keep it in radian mode, we'll talk about radians later on, but if you keep it in radian mode, it's going to give you the wrong answer. Then it's easy. Sine 32 degrees, enter. 0.5299. Cosine 32, do the exact same thing. Tangent 32, do the exact same thing. So we got cosine 32, 0.8480. And finally, the tangent 32 should give you 0.6248. But the problem is here, cosecant, secant, and cotangent, because you don't have anything on your calculator that does that. That's the inverse, not the reciprocal. So, if we want to find the cosecant of 32, you can look back on the notes. The cosecant is simply the reciprocal. Let me go back up here. The cosecant is the reciprocal of sine, and it's also equal to 1 over sine. So if we know sine, all we got to do is 1 over the whatever we have. So the cosecant of 32 would be 1 over 0.5299, or if you want to type it in as 1 divided by the sine of 32, 1.8871. The secant, you type it in as 1 over the cosine. And again, I'm not going to type all these in because, again, this is just calculator work. 1 over 0.6248. You just type it in as 1 over cosine, 1 over tangent, and that will give you the secant and cotangent. Any questions? Nearly finished. Special angles. We're starting to learn how to develop angles that we're going to use a lot. And the way that we're going to do it is we're going to go back and review special angles from trigonometry, or from geometry, excuse me. In a 30, 60, 90 right triangle, this is always true. And this might help you some on your ACTs too, just in case they give you one of these. Did they really? If you have a 30, 60, 90 right triangle, it always looks like this. So here we go, 30, 60, 90 right triangle. In a 30, 60, 90, it says the hypotenuse is double the shorter side, and the longer leg is the square root of 3 times the shorter leg. And it's easy to see why, because if I actually did, let's make up something. If I had the shorter leg as 2, the hypotenuse is 4, you could use Pythagorean theorem and do 2 squared plus b squared equals 4 squared. You're going to get 4 plus b squared is 16. Move it over, b squared would be 12. B would be the square root of 12, which you can split into the square root of 4 times the square root of 3, but notice that's just the square root of 3 times the shorter side. It's always like that. The longer leg will always be the square root of 3 times the shorter leg. Had that been, well, we're working some examples down here, so I don't have to do a lot of that. In a 45, 45, 90, well, if both of these are 45 degrees, then obviously this is an isosceles triangle. So this side would equal this side, and that's what it says. The 2 legs are always equal. And the hypotenuse is always the square root of 2 times the either leg. So if this is 2 and this is 2, this would be 2 times the square root of 2. The reason why, again, the Pythagorean theorem, a squared plus b squared would be 8 equals c squared. So c would be the square root of 8, which again can split into the square root of 4 times the square root of 2. The hypotenuse is always the square root of 2 times either leg, every time. Find the missing measures in each of the following. You have a 30, 60, 90. The shorter leg is always, or the hypotenuse is twice the shorter leg. So what's the shorter leg going to be? 6. And the shorter leg is always across from the shorter angle. So this one would be the longer leg, 6 root 3. That's it. 30, 60, 90 again, but you're given the longer leg. This one's a little bit tougher. If you multiply the shorter leg times the square root of 3 to give you the longer leg, how do you get from the longer leg back to the shorter leg? To get from 2 to 8, you multiply by 4. How do you get from 8 to 2? You divide by 4. Right? So to get from 6 to 6 root 3, you multiply by the square root of 3. If you're given this leg and asked to find this leg, you divide by the square root of 3. So A here would be 4 divided by the square root of 3. Don't leave it like that. Correct? To get from the longer leg to the shorter leg, divide by the square root of 3. How do you not leave it like, or why do I not want you to leave it like that? Square root on bottom. How do you get the square root off the bottom? Multiply top and bottom by the square root of 3. So that would give you, on top, 4 root 3, on bottom, 3. The hypotenuse is always twice the shorter side. So instead of 4 root 3 over 3, you would have 8 root 3 over 3. Multiply it by 2 over 1. And that's it. You can see another one of those. Okay. If you're given 30, 60, 90, this is 30. This is stuff that y'all should have got in geometry. I didn't. That's right. If this is 10, again, well, let's do it the easier way. If this was 5, this would be 5 times the square root of 3, every time. But to go from here back to here, do you see that you could divide by the square root of 3 and you would get back to there? Does that make sense? So if I give you that this is 10, to get back to here, this would be 10 divided by the square root of 3. Yeah, because to get from here to here, you multiply by the square root of 3. To get from here back to here, you divide by it. But we don't want to leave it as 10 over the square root of 3. We want to rationalize that. So multiply top and bottom by the square root of 3. That would be 10 root 3 over 3. So the hypotenuse would be double that, 20 root 3 over 3. And why is double that equal to that? If you multiply by 2 over 1, 2 times 10 is 20 root 3 over 3. It is. You're right. Actually, probably looks better as 10 over root 3. But I don't know. So, how are we going to use that in Trig? Well, let's see. I don't know if it's in this lesson that we get to it. Well, we got 2 more of them. I guess I should. The 45, 45, 90s are easy. If this is 3, this is 3. Because they're isosceles. The angles are the same, the sides are the same. This is going to be the square root of 2 times either leg. Or you could dump Pythagorean theorem, a squared plus b squared, that'd be 9 plus 9, which is 18. C squared is 18, c would be the square root of 18, which if you split, square root of 9 times square root of 2, it's going to be 3 root 2, either way. But what if you're given the hypotenuse and asked for a leg? To get from here to here, you multiply by the square root of 2. To get from here back to here, you would divide by the square root of 2. So that would be multiply top and bottom by the square root of 2. That would be 6 root 2 over 2, which is what? You can reduce 6 over 2. 3 root 2. And this would also be 3 root 2. Any questions? Use the previous examples to evaluate the 6 trig functions of 30, 45, and 60 degrees. This is, I think, the last problem, but this leads us into some common angles that we're going to be talking about in the next few lessons. Let's go back to the previous example, and I hope I still have them there, the different values. Yeah, good deal. We're asked to find the sine, cosine, and tangent of 30, 60, and in a second we'll do 45 degrees. Take either one of them. If I ask you the sine of 30 degrees, go back in what we did a while ago. Sine of 30, opposite over hypotenuse, right? Here's 30. What's opposite? Over hypotenuse 12, which is a half. We'll take the other one. Even though it's 2 different triangles, sine of 30 degrees would be, it's uglier, you would have opposite, which is 4 root 3 over 3, over hypotenuse, which is 8 root 3 over 3. That's nasty. How do you divide that? 4 root 3 over 3 times 3 over 8 root 3, right? To divide two fractions, you flip the second one and multiply, and look at everything that cancels. 3's cancels, the square root of 3's cancels, 4 over 8 is a half. Same thing. So, cross cancel, yeah. 1 and 2. Oh, in this part, what I would do there, yeah, I wouldn't do this next step. I would cross out my 3's. And I would cross out my root 3's and get 4 over 8. You can't do it from there. It's cosine. And we see that it's a whole lot easier to do it on this first one. Cosine of 30 degrees. 6 root 3 over 12. 6 over 12 reduces to 1/2, so a 2 on bottom, so root 3 over 2. Might remember that from last year. Sine of 30 is a half, cosine of 30, root 3 over 2. This is where those common angles come from. And you could do it again for the second one, but I'm not going to. But if you don't write any other notes down for today's lesson, I would write down these common ones. Sine of 30 is a half, cosine of 30 is root 3 over 2. Now let's do sine and cosine of 60, and then we'll move down to our 45s. Sine of 60. Here's our 60 degrees now. Sine of 60 would be opposite over hypotenuse. What's opposite? 6 root 3 over 12. That's the same thing as down here, right? Root 3 over 2. The cosine of 60 equals a half. Because cosine of 60 would be adjacent, which is 6, over hypotenuse, which is 12. Tangents for each. I forgot about tangent. Tangent of 30 degrees is opposite over adjacent. What's opposite? 6 over what's adjacent? So 6 over 6, that's going to be 1 over root 3, which rationalize that, multiply top and bottom by what? Square root of 3, so that's going to be the square root of 3 on top and what on bottom? So tangent of 30 is root 3 over 3. We're deriving all those things that we learned last year. And finally, the tangent of 60, let's take here's 60, opposite over adjacent. Opposite would be 6 root 3 over 6, which is just root 3. So sine of 30, 1/2. Cosine of 30, root 3 over 2. The tangent of 30, root 3 over 3. Sine of 60, it's root 3 over 2. Cosine of 60, 1/2. Tangent is square root of 3. Now we're going to do 45 when we're done. I'll come back up if you didn't get those wrote down. The sine of 45 is opposite over hypotenuse. Here's 3 over 3 root 2. Is that what you said? And you're left with 1 over root 2 because the 3's cancel. Rationalize, what is that? Root 2 over 2. Questions? Cosine of 45 is going to be the exact same thing because here's 45 adjacent is 3, hypotenuse 3 root 2, so you get the same thing. And the tangent 45, what's opposite over adjacent? 3 over 3, which is 1. Like Cody said, tangent 45 is 1. And it doesn't matter if you use this one or if you use this one. The tangent of 45 is always root 2 over 2. The cosine of 45 is always root 2 over 2. The tangent of 45 is always 1. I think I said that backwards. Sine is root 2 over 2. Any questions?